Okay. Well, let's talk a tiny bit about Friday. On Friday, we have our midterm exam, and so the last quarter's midterm has been posted for you guys to use as kind of a study aid. I've also listed off some of the topics that will not be covered. Okay, with kind of the note that everything else is fair game for the exam, and I hope it helps you prepare. I've seen some questions on Piazza regarding some of the midterm content and things of that nature, and you know, I'm happy to try to answer those things. And I've seen a lot of good responses from other students on Piazza as well. So thank you to you guys who are answering each other's questions and contributing in that way. Regarding Friday's midterm exam, I will be using a seating chart, okay? And this is something that, you know, I didn't want to do, but last quarter there were some issues, and I think those issues could have been avoided if I used a seating chart. And so just kind of preemptively, I'm going to put in a seating chart. The way the seating chart will work is basically maybe about 2 hours before the exam, I'll email it out. Okay, it'll just be a PDF, and it'll show kind of the seats, and your name will be there. Please take a look at where you will be seated, and that way when 1 o'clock rolls around, you'll know exactly where to sit down for the exam. We won't be wasting any time about who sits where and whatnot. If you have a special need, such as you need to be seated in the front row or need to be seated in a left-handed desk or something like that, send me an email, please. I would say today, and I will try to accommodate those requests. But for the most part, I'm just gonna do kind of I'm gonna just use R to randomly assign you guys a number from 1 through 100 something. 107, however many there are of you, okay? And then I'm just gonna kind of fill out the seats accordingly. So, so it's just gonna go that way. So, you know, by random chance, you might sit next to someone you know, but chances are, well, I guess that depends on how many people you know, but it's just gonna be random, okay? Okay, are there any questions about the exam? Yes? Today's material will not be on the exam. So the exam covers up through Monday, which we did regular expressions, and that will be the last topic covered on the exam. So it covers, there's a lot, I don't know about a lot, but okay. I'd say heavy emphasis on data types, heavy emphasis on flow control in terms of loops and if statements, and how those things work. Emphasis on scoping, so when variables are defined and where it searches and things like that. And then stuff about, there's a few questions on tidyr and regular expressions and things like that. I do feel like the last quarter's midterm is I don't know what's the best word to use. Is of the same, quote, flavor as the midterm that you guys will see, okay? Of course, the questions are all going to be different, but in terms of the nature of those questions, there are some similarities. Okay. I know it's a lot of material. I know it can be intimidating. And I know there's other exams going on, and it's midterm week, and everybody at school has tests and stuff. Just during this time, and I'll say this over throughout the quarter, is that your performance on an exam is not a reflection of who you are as a person. Okay, whether you do well or whether you do bad, it has no bearing on on who you are, okay? It does feel good to get good scores on exams, I recognize that, and it doesn't feel good to get bad scores, but even if you get a bad score, it's okay. And even if you get a great score, it doesn't mean you're suddenly better than you were the day before or compared to other people. So, okay. Any questions? Yes. How much dplyr do you need to know? I'm not sure how to answer that question. Are you responsible for knowing some dplyr? Yes. I guess, you know, I won't run, like on dplyr, they have like special functions that exist only in dplyr, such as selecting columns that starts with or ends with or things like that. I guess it'll be fairly, in my opinion, standard dplyr, but I don't know how to answer this question because my judgment of what's standard may be different from what your judgment is. I would say if you understand the dplyr use in homework 3, you'll be fine. That doesn't mean you have to have completed homework 3 though. Okay. Any other questions? Okay, then we'll get started on covering ggplot2. Whoops, what happened? So I'm in debate. So we're not going to get through every single slide in today's lecture, and I'm debating whether I should continue this on into sixth week Monday, or if I should just let you guys browse through these slides on your own time. So we'll see, okay? Have all of you guys had worked with ggplot already, yes or no? Okay, some of you are nodding and some of you are shaking your heads, so, well, I guess we'll deal with it today. So, okay, ggplot2. So, this is just it's another way of creating plots in R, and I'm not saying that ggplot is the best way to create plots, but there is a certain elegance and simplicity to the use of ggplot once you understand how ggplot works. Okay, if prior to that, then ggplot can seem a little bit overwhelming, and because there are a lot of different things going on. I think you guys are familiar with the base graphics in R, using just regular old plot and all of these other plot features and functions, and that's good and great, and I still very much use base graphics all the time. However, if I'm going to build up a plot that is, you know, more complex than a simple scatter plot or things like that, then sometimes ggplot makes it easier. Okay, so I guess kind of my rule of thumb is if it's a very simple plot and you just need something up and running quickly, then base graphics will do the job. If your plot gets more and more complex, then doing the complex plot in base graphics can become tedious, and using ggplot can make it easier, okay? However, for the simplest of plots, then ggplot might be a tiny bit overkill, although the plots that ggplot makes are generally, quote, beautiful. So, all right, anyway. The GG in ggplot stands for Grammar of Graphics. It's a system created by Leland Wilkinson, and it kind of provides a formal, structured perspective on what exactly data graphics represent. Okay, and that's kind of the key system that you have to understand in being able to use ggplot. Okay, and I think all of this stuff is what I said about base graphics versus ggplot. It's not to say like one is better than the other. Okay. The idea behind the grammar of graphics is that you have data, and what the graphic does is it maps the data, the information in the data, to a visual property. Okay? So for example, you might have a column of numbers, and what a scatter, you have two columns of numbers, and what a scatter plot does is it maps one column to the x-axis, the position in the x-axis, and it maps the other column of values to the position in the y-axis. Okay? And once you understand that, then your eyes are able to look at a graph and detect patterns and things of that nature. Right? You probably created your first scatter plot in what, 5th grade or something like that? I don't know. When did you guys make your first plot XY coordinate pairs? 4th grade? Something around there, right? Like you probably had like, we're gonna make pie charts and like bar graphs and I don't know. This was when I was in 4th grade, but that was a long time ago. Well, anyway, all right. Okay, so you have either numeric or categorical values, and visual properties are things like the x and y position. There are also things like the color of the line or the height of the bar, and basically you are just mapping some property of the data to some visual property, okay? And then the idea is that once you've mapped the numeric or categorical data in the data to a visual graphic, and you present the graphic, the viewer then views that graphic and inside their brain maps the graphic properties back to data, okay? And it sounds a little bit silly, right? Like, why would we go map data? It's like putting things through Translate, right? Google Translate, right? You're translating data to a visual, and then your brain uses your eyes to translate the visual back to data. However, that process allows your brain to detect certain patterns that it would have a much more difficult time detecting if it looked at the raw data itself. Okay? That's the whole purpose of a graphic, is to map data to a visual so that the viewer can map the visual back to the data inside their head without having to look directly at the raw data. And if you have this in mind, I think it helps make things a little bit more sense. So right here I say, on the surface, representing a number with an x-coordinate may seem different from representing a number with a color of a point, but on an abstract level they are the same. We are just mapping a data property to a visual property. And so when we do the grammar of graphics, this is kind of the central thing. We have something called an AES, an aesthetic mapping. And we just say this aspect of the data is being mapped to this aesthetic property, okay? And so let's say we have this simple data set, okay? It's categorical data. We've got two categorical variables. Variable A, which has 3 categories, A1, A2, and A3, and then variable B, which has 2 categories, B1 and B2, and here we're just providing some counts of each of these things, right? So we have A1, B1 is 10, and A2, B1 is 7, and so on and so forth. With base graphics, we would do something like bar plot, and we would say, we would just provide it this table, and then we would see the plot being produced. So we go, okay, A1 and category B1 is 10, A1 and category B2 is 9, A2 category B1 is 7, so on and so forth. And this is plotted this way. Okay. However, what if we wanted to create, rather than having A1, A2, A3 be the categories across the bottom, we wanted B1 and B2 to be the categories across the bottom. And B1 would have three columns, and B2 would have 3 columns. how would we do that? This is basically what we are going for. In order to change this in base graphics, what we have to do is we have to restructure the data. Over here I've got a 2 by 3 matrix, and I would have to transpose it so I have a 3 by 2 matrix. And if I throw that into bar plot, then I get what we want. And this is essentially the quote problem with base graphics, is that if you want to make changes to certain properties of your visualization, changing the way we've mapped basically the columns or the information, variable A and variable B, changing the way we map that is not necessarily intuitive or simple, okay? I mean, it's simple in that we just transpose the data, but what you're effectively doing is you have to entirely restructure the data. And this can become a problem in anything that's more complicated than just a data set with 2 categorical variables. So how would we do something like this in ggplot? Okay. Well, if we think about what we have in ggplot, is we've got 2 variables. We've got variable A and variable B, right? And how many observations do we have? We have a total of 6 observations to plot. And so, sorry, I'm getting ahead of myself here. If instead of bar plots we wanted to do line graphs, we can do this, okay? So I would take this data set, okay, and I would say, let's look at the first row, and I would say create a plot of the first row in simple data using type L, and it creates this line that goes from 10 to 7 to 12, which is what our data set has, 10, 7, 12. And then the other plot goes from 9, 11, 6, okay? And so to add that line, I would say add a line using the second row of simple data 2, and it goes from 9 to 11 to 6, and I'll say use the color blue. Okay. What we notice is that there's a few quirks here, and one is that the 6 dips below the kind of the span of the screen, okay? And that's because the range on the X and Y axes were established during this plot command, and it just adds a line using the current axes without kind of reshaping it. And then the other thing is that the index appears to be presented as a numeric variable rather than a categorical one. Okay, so it says like 1.0, 1.5, 2.0, 2.5, and 3.0. I think somebody could be misled to believe that this is numeric because it's providing decimals. Okay, all right, let's talk about how we would want to do this in ggplot. In ggplot, we would have to restructure our data into tidy form, okay? So you could use gather in this case, right? And we would gather all of the numeric values into one column, and we would have to have a column for the A variable and a column for the B variable. Okay, and so here our 6 observations say, you know, A1 and B1 has a value of 10, A2 and B2 have a value of 9, so on and so forth. Okay, each variable has its own column. That's the key for ggplot. ggplot requires data to be in tidy form. You can't have kind of this, you can't give it a two-way table, right? You've got to give it data in tidy form. So you use gather, you get all the variables into one column. And now what we want to do is we want to create a bar graph. And what we are going to do is we're going to say based on the values in A, in the column A, we are going to create different, we're going to put the values that have A1 into one spot on the x-axis, the values that have A2 to another spot on the x-axis, and the values that have A3 to another spot on the x-axis. Okay? So therefore, the aesthetic mapping is that the x position is determined by the A value column. Okay? Because A1s will appear in one position on the x-axis, and A3 and A2 will appear in different positions on the x-axis. Okay? And then we will change what the color of the bar will be determined by the B value. So we will say the fill color is mapped to the B value column. Right? We're going to, the default behavior is that the B value column would get stacked on top of the A value column. And so we're going to give it an option called dodge that says put the values side by side. Okay? But anyway, I'll explain that. And then the height of the bar is determined by the value column. Okay, so we have one more mapping, and I missed the bolding, is that the height of the bar, y, is determined by the value column. So this is the mapping that we have. A values are mapped to x, B values are mapped to the color fill, and the value column is mapped to the height of the bar, y. Okay? And we tell it to draw the bars using geom_bar. This means add geometries to our plot. And this is our plot here. We call library ggplot2. We're going to say our data comes in simple_dat_long. This is our tidy data form. We say we've mapped A value to x, y value to the y, and B value to the fill. Okay, and we say geom_bar. There's a couple things here. Dodge puts the, rather than stacking the B2 values right on top, which is the default behavior, it puts it right next to it. And then stat equals identity tells it to actually use the value in the value column rather than trying to tally them up. Okay? But this is the plot that we've created. Okay. Does it make sense that the A value is being mapped to the x-axis? Yes? No? Okay. Okay, so if I wanted to switch the groupings so that I've got a group for B1 over here and 3 columns, 3 bars side by side, and then a grouping over on this side for B2, what would I change in my aesthetic mappings? Okay, what would I map to the x? B value would be mapped to the x. Okay, what gets mapped to the y? Value remains mapped to the y, and then mapped to the fill would be A value. Okay, so that's exactly what we would do. And I would just do B value gets mapped to x, value remains mapped to y, A value gets mapped to the fill, and it changes the plot here. Okay, so there's no restructuring of the data. We just change which columns get mapped to which properties. If I wanted to make a line plot, okay, we do something similar. We say, in this case, the A value can get mapped to the x. Okay, so we'd have A1, A2, and A3. And then the values get mapped to the y. And then the color of the line gets mapped to the B value. B value gets mapped to the color. They might have fixed this in a later release. The person who created ggplot is Hadley Wickham, and Hadley Wickham's from New Zealand, and so they spell color with a U, and summarize with an S and things like that, right? So that's what we have. Okay, and we say the geometry of what we are drawing will be lines. Okay, so kind of just in summary, with base graphics, we had to use completely different commands to make a line graph instead of a bar graph. With ggplot, all we have to do is change the geometry from bars to lines. Okay, another aspect is that the plot will fit the data. Okay, so even though this goes down to 6, ggplot recognizes that and makes the plot fit that. And we also see that the x-axis is kind of represented categorically rather than as numbers. And it also generates legends for us, which is nice. Okay, I don't know if you've ever tried to add a legend to a plot in R using base graphics. It's like a pain in the butt, right? You gotta say, like, I want to position this, and you got to give it coordinates on the plot of exactly where the legend is going to start, and then you got to. It's not fun. ggplot adds legends to us very nicely. Okay, so a few terms, and we've covered some of this already. But the data is the thing we want to visualize. It consists of variables, which are stored as columns in a data frame. So our data is always in tidy form. Geomes are the geometric objects that are drawn to represent the data. Okay, your most common geomes will be lines, bars, and points. So we'll cover those, and then I'll point you to other resources. Okay. The aesthetics, these are the visual properties of the geomes, such as the x and y position of the point, or the color of the point, or the symbol of the point, or the positions of the lines and things like that. We map variables, the columns, to these aesthetic properties. Scales control the mapping from the values in the data space to values in the aesthetic space. So what does that mean? So you might have one column of heights, okay, the height of people. So the data space would probably cover values between 4 feet and 7 feet tall, okay? Or, probably 4.5 to 6.5 feet tall. That's probably a realistic range of the largest and smallest values you will see in your data space, okay? In the visual space then, the bottom, you have to decide, does 4.5 feet go to the bottom of the plot, and 6.5 feet go to the top of the plot, or should the bottom of the plot be at 0? Okay, and this is an important question, right? Because people might complain that your graph is misleading if it doesn't start at 0 at the bottom. Maybe it should, maybe it shouldn't. These are all decisions that you have to make in terms of the scale. Okay. Or maybe your data space is a categorical variable that goes from strongly disagree, disagree, neutral, agree, strongly agree, or something like that. You've got kind of 5 categories. And you want to map this to colors, okay? The scale there, so the data space has those 5 categories, and the visual space will then need to have 5 categories. And you might have, this is a choice, but it probably makes sense to have a scale that goes from like red to orange to yellow to light green to dark green, or something like that. Or something where our brains understand there's kind of a gradient shift going from one to another, right? If you chose colors of the rainbow and you said strongly disagree is red, and I don't know, and you just kind of mix these up, and you said, and then just regular disagree is blue, and then neutral is purple, and agree is pink, and strongly agree is brown, and then you plot this, people are going to have a hard time with this kind of information, right? So your choice of scales are important in terms of how do you map from the data values to visual properties, right? And then on the flip side are guides, right? So when you look at a plot, look at a graphic, your brain needs to go from the graphic information back to you're generating the data in your head. And so those are things like tick marks that allow you to see, like if you see the plot and there's no axis labels, then you have no idea what the high part of the bar and the low part of the bar represent. So guides help you understand, like, oh, is the bottom of the bar 0 or is the bottom of the bar 4.5 feet? Okay, or the legends, such as, oh, red means strongly disagree, or red means strongly agree, or something like that. Okay, so those are all things that serve a purpose in a graphic. A graphic that has no guides is almost entirely useless, because you are not able to map it back to data in your brain. Okay, your typical graphing scenario. Okay, you've got data. You add some geometries. You'll have an aesthetic, and then you've got scales, and you might choose a log scale or something like that. Okay, and these aren't the only things possible, but that's what we got. All right. Common. So we'll have the data types can be either numeric values, categorical variables, even text strings, and commonly used aesthetics include, you know, horizontal and vertical position, color, size, and shape. And so you've got to kind of make a choice. Things like horizontal and vertical position can be used for either numeric or categorical data. Things like color can also be used for numeric or categorical data. Categorical data, you do things like red and orange and yellow and green, things like that. If it's numeric data, you can have color go on a gradient from like white representing 0 to, you know, different shades of gray, all the way up to black representing 100% or something like that. Or you might have some other kind of gradient transition that also makes sense, right? Like we're probably accustomed to seeing red and blue representing right-leaning and left-leaning for you know, political opinions. And that, well, that first of all, that puts political opinions on a single unidimensional scale, which is probably not the most accurate thing to do. But let's say we did have one variable that measures right to left leaning, that could then be represented with, you know, different shades of red or blue. Whereas other aspects, such as the shape of your point, whether it's a star, a circle, or a triangle, those only make sense for categorical variables. It doesn't make sense to try to do that with a numeric one. I guess this is what I said. Okay, so shape only works with categoricals. Some things work with both, and whatnot. If you're going to alter the size of a point, okay, the size of a point, would that make sense for numeric, categorical, or both? I would say the size of a point really makes only sense for numeric, okay? Yes, you could have the size be mapped to a categorical, but then who gets to decide whether red should get a big point? I mean, like a categorical thing, right? Gets a big point or small point, right? So it makes sense to map it to a size attribute. You might have to discretize your numeric thing. So, for example, on a map, they often represent cities with different sized dots, okay? And usually, I mean, the dots don't vary too much in size, but like big cities will have like a slightly bigger dot than the tiny cities. And they might take that numeric variable and say like, cities under 100,000, cities under 500,000, cities over 1 million, and things like that. Okay, let's talk about building a simple graph, all right? So here, I've got a data frame in tidy form, an X variable, a Y variable, and a grouping variable. Okay. You start off, and in this case, you just map. So this is our data frame, and you'll do an aesthetic mapping, and you'll say, we're going to map the X value column to the X attribute and the Y value column to the Y attribute. Okay. Here we have not plotted any geometries, and so what we have is an empty plot. If we want to add something such as points, we can do that. All right, and so yeah, all that we've done so far is we've mapped the column X val to the X position and Y val in the Y position. This is all done inside the argument or the function AES, AES for aesthetic mapping. Okay, and ggplot, we haven't told it what kind of things to plot, and so we will say add some points. We're going to add geometries, points. Okay, and so I just say X val, Y val, add point geometries, and there we go. Okay, it has added points to our plot, and we can kind of go back and we can see, okay, we've got 1 and 3, 2 and 5, 3, 6, 4 and 9, and that's what we have. 1, 3, 2, 5, 3, 6, 4, 9. Okay, and so points are added to the thing. There's another column in our data, which is the grouping variable, right? The group variable, it's either A or B, and so the color of the plot will be determined by the variable group. And so inside geom point, inside the point geometry, we're going to say here's an aesthetic mapping and change the color of the plot, color of the point based on the group variable. So we'll put the aesthetic mapping inside the point geometry. And I don't know if you guys can see it, but we now have, what is this color? Salmon, red. And over here is like a teal color over here for, and we have a legend to help us understand that. Okay. Aesthetic mappings mean a variable in the data determine an aesthetic property, such as the color of the point. We also have settings, okay? Settings are not mapped to variables. They are just settings. Like, let's say you want to change the color of the point, and you want to change all the points to blue, you can do that, okay? The color is now a setting and is not linked to any property of the data. So in this case, I would just say geom point color is blue, and all the points just become blue. On the projector, it looks black, but they're blue. Okay. And so this is there's no data being conveyed by the color of the point. Okay, so that's the important attribute. Important thing to understand is that if some visual property is conveying information about the data, it's an aesthetic mapping. If it doesn't convey any information about the data, then it's just a setting. So here, because all the points are blue, blue does not give us any information about the data itself. We can change the scale. So here, the bottom is 3 and the top is 9. Or I'm sorry, the x-axis, the leftmost point is 1 and the rightmost point is 4. If we wanted to change the scale, we can say, I want the leftmost limit to be 0 and the rightmost limit to be 8. Okay, and this is done using scale underscore x underscore continuous. Okay, now you might say, well, how am I supposed to remember scale underscore x underscore continuous, and how am I supposed to know all of these things? Okay. Well, this is where documentation comes in. So all you do is you just go to, I guess, search Google for ggplot2, and Either of these things will take you there, okay? The first link will be ggplot2.org, and then you go to the documentation, docs.ggplot2.org, and then you can see all of these things, right? Contents, I want to change scales, and there's all of these different things, okay? So you can click any of these things and it will give you very thorough documentation, okay? The other thing is you just say ggplot, how do I change the X scale, right? And then somebody on Stack Exchange or Stack Overflow will, oh, this is not from Stack Overflow, but this is from somewhere else. Somewhere on the internet, somebody has probably done what you're trying to do and will have an answer for this, right? Okay, how to set limits for axes in ggplot, right? So you just say, oh yeah, that's exactly what I was trying to do. And then you go, and then you see, okay, this, and then somebody says, oh, look at that, scale X continuous, right? Another great resource is on ProQuest. Go to ProQuest.Safari Books Online, and inside the O'Reilly catalog, there's something called the R Graphics Cookbook. This is an excellent resource. I think I have it linked in the syllabus. The R Graphics Cookbook. This covers a lot of use of ggplot, and usually you can kind of go in here and say like, I don't know, whatever it is that you're trying to do, right? Changing something. Here, swapping the X and Y axes. How do you swap the X and Y axes? Basically, it just says you change the mapping, or I guess you can do, there's an option called coordinate flip. You know, there's all these different things that you can do. So the R Graphics Cookbook as another great resource here. Okay, are there any questions so far? Okay, if you wanted to have control over, so we'll go back to an aesthetic mapping. So now group is being mapped to the color attribute. So the color of the point will convey information about the group variable. But let's say you don't like the default colors, okay? Well, you can change that using some option like Scale Color Manual, okay? And then here we can choose orange and forest green, and I don't know the listing of all the colors that R recognizes, but you know, you can provide R hexadecimal color references, and there's also a listing of words that it recognizes as colors. Forest green is one of them, and it's hard to see on the plot on the screen here, but indeed the colors have changed. Here's an important thing, okay? When you create a plot with ggplot, okay? So here, all of these things I've said P plus these things. At the very beginning, we said we're going to create an empty plot, and we're going to call it P, and then we just add geometries to it. Okay? In R, whenever you type something in, let's say you have the value, you say X is 2, and then you later on type X, the default action that R does is it prints out that thing, okay? And so oftentimes when you create plots in R using ggplot, it'll print it out to your plotting device, okay? But if you write a script or something, you put it in your markdown file, the plot, well, let's say you've got a loop and you want to produce different plots. If you just type in the word X or the character X into a loop, it's not going to do anything, right? Like if I do for I in 1 through 10, and then I just say I, does this do anything? It doesn't do anything. If I want to actually see what I is, I have to say print print I, and then it will print out these numbers. Similarly, if inside your loop you create, you do something like ggplot, blah, 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 okay? If you do this, it is not going to actually display the plot. What you need to do is you need to say P is the result of what ggplot produces, and then you need to say print P, okay? In the same way that a for loop for I and 1 through 5, if you do this, in the same way that this does not output anything to the screen, producing a plot without calling print, this will produce something to the screen, right? In the same way, you need to call the print command for a when you produce plots with ggplot. Okay, especially if you call it in a loop. Okay, but the default behavior with the console is that when you type out something, it generally prints out that result. But if you have it in a loop or in a script, you'll have to call the print command. Okay, ggplot has some things called stats built in. So for example, if you in R, if you create a histogram, the process of creating a histogram involves some intermediary steps, right? If I gave you a raw data table and I said make a histogram, you can't just go from the raw data table to a histogram. You have to create a frequency table in between with bins, right? You've got to say, I'm going to count values between 0 and 9.99. I've got 5 of them. I'm going to count values from 10 to 19.99, and I've got 12 of them, or something like that. You're creating an intermediary table before you create your histogram. ggplot calls any kind of step like that a stats step, okay? You're calculating statistics based on the data before you do that. So these are often included for you if you say, I want a histogram. geom_histogram will automatically do this for you. However, if you have some kind of new plot that doesn't already have a geometry built in, you might have to do these stats things yourself, okay? I guess we can talk more about this during 6th week, covering some of the basic geometries of points, lines, and bars. But you can go ahead and take a look, I guess, over the weekend. But good luck as you guys study for the midterm exam, and check your emails for a seating chart about 2 hours before the exam.